k number of Gaussians. So for every Gaussian we require a mean, so that mean is denoted with the mu. So here mu1 is indicating first Gaussian distribution mean value, mu2 is the second Gaussian distribution mean value, mu k is the kth Gaussian distribution mean value. Okay, so here the tuple of these means are considered as our hypothesis. Okay, so the learning task of this entire thing is, so we are giving the best hypothesis, that is H. Okay, so here to identify this one, so we need to find the maximum likelihood hypothesis for these means. Okay, so whatever the means we are considering, so for this we need to identify the what is the maximum likelihood hypothesis. So here that is maximizing the probability of D conditioned on H. We know that the D is the data which we have, and here H is our hypothesis. Here our hypothesis is tuple of mean values. So here we are considering the given observed data instances as x1, x2 up to xm. So it means that our D contains x1, x2 up to xm as the data instances. So here initially we are considering a single Gaussian. Actually we need to find the mean of the k Gaussians. So to find that one, initially we are considering a single Gaussian only. So in the single Gaussians we are having, these are the data instances, and here these are drawn from a single distribution, that is form a normal distribution. Here our goal is to find the mean of this particular distribution. So how we are finding the mean for this one? So we know that if we have a single distribution, it's very easy to find the mean. So that is our sample mean only. This is the formula for sample mean. Okay, but here maximum likelihood estimation of the mean of normal distribution can be shown be one that maximizes the sum of squared errors. Okay, so here this is the sum of squared errors. So to minimize this one, we need to estimate our maximum likelihood values. Okay, so here from this we simply conclude the sample mean formula as, so mu ml, this is the maximum likelihood mean, which is equal to sigma I equal to 1 to m xi by m. It's nothing but this is a normal mean function. Okay, so if we have a single Gaussian or single normal distribution, then the mean of that particular normal distribution is easily identified. So with the help of this particular formula, this is the known formula for us only. Okay, so the problem is whenever we are having more than one Gaussian function, more than one Gaussian distribution, so then how we are finding the mean values for them, and how we are finding the maximum likelihood estimation of those means. Okay, so here we are considering mixture of two Gaussians, that is our k value as the 2. It means that we are having two Gaussian distributions to distribute our data. Okay, so here we cannot observe as to which instances were generated by which distribution. So we know that if we have the two distributions, suppose this is one of the distribution and this is another distribution, then if we are considering this as one of the instance, then we are unable to identify that whether this particular distribution is generated this instance, or this distribution is generated this particular instance. So this is main problem in if we have more than one Gaussian distributions. Okay, so here we need to identify that which Gaussian distribution is generated this instance. Okay, so here our with the help of our EM algorithm we simply do that one. Okay, so here these are the basis for to identifying that. So here to move on to the EM algorithm which is used to identify this one, so first of all we need to know about the notations which are required for this. So here the instances which we have, they are described as the tuple of three things. One is xi, zi1, zi2. Here xi is the instance, and here zi1 and zi2 are the two distributions which we have. Here zi1 is zi1 or zi2. So these are including which of two normal distributions was used to generate our xi. It means that whether xi is generated by first distribution or second distribution, we need to identify that. Here zi1 is indicating that, so this xi is generated by this one, and zi2 is indicating that xi is generated by this second distribution. So here this Zi1 and Zi2 are having either 0 or 1 value. So here 0 is indicating that so this particular instance is not generated by this distribution. So if the value of Zi1 is equal to 1, this one indicates that so this particular distribution is generating this xi value. Okay, so see here Zij is equal to 1 if Zij was used to generate xi 0 otherwise. Okay, if xi is generated by the jth distribution, then we simply says that Zij is equal to 1. If jth distribution is not generating the xi, then we simply conclude that our Zij value as the 0. Okay, in the similar manner we need to consider these two values. Okay, so here this Zi1 and Zi2. So if you are considering this particular tuple, so here we have these three things. Na? Xi is the instance, data instance which we considered. So this one must be generated by one of the distributions among the two distributions. So which one is generated? That one is indicated by these two variables. Okay, if this value is 1, then and this value is 0, then we simply conclude that xi is generated by the first distribution. Okay, so these two variables are the hidden variables, so and which are have the probability distributions associated with them. Okay, so here we need to identify these values with the help of our EM algorithm. Okay, so here this is the diagrammatical representation of our distributions with the hidden and specified distributions. So see this one, on the x-axis we are taking the instances, on the y-axis we are taking the probability density function, and this is first Gaussian distribution and this is the second Gaussian distribution. So if you consider this particular instance is denoted as the xi comma 1 comma 0. So it indicates that this particular instance is generated by this distribution. This is the first distribution. Na? So here Zi1 value is the 1. So it means that first distribution is generating this xi value. Okay, and Zi2 is the 0. This one indicates that the second distribution is not generating this instance. Okay, and this mu1 is the mean of this particular distribution, mu2 is the mean of this particular distribution. Okay, so here with the help of our EM algorithm, we need to identify these hidden variable values. It means that Zi1 and Zi2 values. Okay, so here we need to go with two-step process similar to our generalized EM algorithm. Here we need to initialize our hypothesis H as the tuple of mu1 comma mu2. Why we need to consider only two mean values? Because here we are considering k value as the 2. K is 2 means we are going with two Gaussian distributions. So mu1 is indicating the mean of first distribution and mu2 is indicating the mean of second distribution. Here we need to initialize these two values and we are considering this tuple as our hypothesis. Okay, and in the step 1 we need to calculate the expected value of the z value, z. It means that E of Zij. It means that we need to estimate the values for Zij. Okay, so Zij are the hidden variables which are giving us that our instance is generated by either the first distribution or second distribution. Okay, so to estimate this one we need to consider whatever the hypothesis we are having. So initially we are taking H as the mu1 comma mu2 na. So by using this one or by assuming this one, we simply estimate or expect the values of Zij. So this is the first step. In the second step we need to calculate the new maximum likelihood hypothesis by assuming the values taken by the each hidden variable Zij and replace the H with mu1 comma mu2 with the new hypothesis H bar, that is mu1 bar comma mu2 bar, and iterate these steps until convergence occurs. Okay, so it means that whatever the estimated value we have, so with the help of that particular estimated value we need to calculate the new mean values for each and every Gaussian distribution. So if after finding these new mean values, we need to replace these values with our old hypothesis, and these two steps need to be repeated until the convergence is occurred. Okay, so this is how we are applying our EM algorithm for finding the estimate means of two Gaussians. Okay, so these are the formulas which